A pulley with a radius of 12 inches uses a belt to drive a pulley with a radius of 7 inches. The 12-inch pulley turns through an angle of 120 degrees. Find the angle through which the 10-inch pulley turns. State your answer in both radians and in degrees. So let's go ahead and just draw a picture of what's happening here, and I'm going to just do a side view. Okay, I've got, let's make it a little bit bigger. Here's my pulley of radius 12 inches. Okay, so 12. And I've got another one of radius 10 inches. Okay, and we've got a belt that's connecting these, and so we can think of it as kind of going around. Okay, this belt that's wrapping around the two. And I'm sorry. I think this is stated wrong. He used a belt to drive a pulley with a radius of 7, and then we've got this random 10-inch. Let me fix that. So this right here should be 7 inches. Now the question actually makes sense. All right, so we've got our pulley of radius 12, pulling a pulley with a radius of 7. All right, so this pulley that with the 12-inch radius that rotates through an angle of 120 degrees. Okay, so if I draw that, that's going to be something like this. And so we can think of this, if this rotates, okay, like this, then we can figure out the distance that the belt will move. That distance is going to be this length right here. So that's the arc length. And I know that that's going to be the same distance over here on the 7-inch pulley. Let's go ahead and find that arc length. So arc length is given by the radius times the angle measured in radians. I'm going to need 120 degrees in radians. So we're going to convert that by multiplying by pi over 180 degrees. Okay, and that comes out as 2 pi over 3. We've got a common factor of 60 here. And so now I can find that length, this length here, S, and that is the radius, which is the 12 inches, times the 2 pi over 3. Okay, and that gives me 8 pi. Now, that length, that is the same arc length over on the 7-inch pulley that the belt travels through. And so we can take the same formula and say, well, now I know that R times theta for this 7-inch pulley has to equal the 8 pi. Okay, now I actually know the radius, so I'll go ahead and plug that in. I have 7 times theta is equal to the 8 pi. We can divide both sides by 7 here and get the angle that the 7-inch pulley travels through, and that is 8 pi over 7. Now, this process that I did, I looked at these arc lengths separately, but we could actually do it at the same time. Let me go and show you that real quick. We could say that I'm going to do this with subscripts, R1 times theta 1 is equal to R2 times theta 2, where we're referring to the first pulley and the second pulley. We know that the arc lengths have to be the same that the belt travels. And so then we just plug it straight in. And for this, you actually don't have to convert to radians. You can just leave it as the 120 degrees. And then over here, the 7 times, we don't know that angle, theta 2. And then we can divide by 7, okay? So we have 12, well, let me go ahead and write that out. We've got 12 times 120, which is 1,440 degrees over 7. Okay, and that would be my second angle. Now you'll see here I got a degree measure, and here I got a radian measure. And if we convert between the two, we should end up with the same thing. And I'll just show that real quick. If we take the 8 pi over 7 and multiply by the 180 degrees over pi, okay, the pi's will cancel. 8 times 180 is 1,440. And then over 7. So those are two different ways of approaching this problem. You can find the arc length of one, then go do the arc length formula for the other, plugging in that arc length that you know, or you can just set those two arc length formulas equal to each other and plug in everything that you know.